Welcome to the this will be lecture 6, right? Welcome to our algorithm analysis course. So in this lecture we will discuss the complete Heapsort algorithm, and we hopefully with an example in either C++ or Java or C#. Okay, so let's get started. So before we start, so let us do a quick review in our previous lecture. So in our previous lecture we discussed heap, right? So in order to discuss by Heapsort, we discuss what is heap. A heap is a kind of binary tree, right? So heap is a kind of binary tree that is implemented in as an array in computer memory, and we discussed that a heap is a complete binary tree. So this is incomplete, right? So right one is incomplete because this it does not have this element. It is missing. Actually this element should go here, this element should go here, and this element should go here. Okay, and we saw that so this is a heap, okay, in binary tree format and in heap array format. Okay, so then we discuss how to remove an element from a heap, okay, by removing the last element, in decreasing the n, okay, number of elements, and we discuss how to insert an element in a heap, okay, by when we insert then we increase in element 1, right, n plus 1. Okay, so another important property is that in a heap all parent elements, or if a parent element is greater than or equal to both of its children elements. Okay, so this is the left child and this is the right child. Okay, so then so if index start with 1, so in the old school format, in pseudocode format, actually the book has the description with index 1. So the parent index will be the floor of I by 2, and left element will left child will be 2i, okay, 2 with index 2i, and then right one will be 2i plus 1. Okay, and another thing is that this is the important heap property, that every parent element is greater than or equal to all of its child elements for all I. Okay, and then heap height is log n, right? So and we discuss the Heapify algorithm. Heapify algorithm is used to ensure that the binary tree maintains all of the elements. The binary tree maintains the heap sort, the heap property. Okay, that is the all of the parent element is greater than that is children elements. If it is not, then what we do? We do some swapping and we make sure that the heap becomes a heap. Okay, so actually it maintains all of the elements, maintains the heap properties. That means, and then we discuss that what is the time complexity for doing that is the log n, right? So that is the log n, a log n, this is the height, okay, of the tree also. Okay, so this lecture we will start from there that we discussed in our previous lecture, and then hopefully we will complete this Heapsort algorithm today with an example. So how to today we'll discuss building a heap and Heapsort algorithm, right? So that we discuss in heap properties, okay, and then we discuss this and we left here. So then how do we build a heap? Okay, so we can build a heap by bottom up manner by running the Heapify algorithm that we have, and then to convert all elements from, so this is in pseudocode format, index with 1 to n or 0 to n minus 1, where n is the length of the array into a heap. So then for an array of length n, all elements in the range a of floor n by 2, okay, starting from n by 2. Why do we need actually n by 2? That's actually the heap has height n by 2, right, plus 1. So then since we will take floor and then plus 1, then we will get the middle element, and actually we will starting from here we will go all elements, then actually we will decrease by the index by 1, okay, every time, and we will process. So that is that the build heap algorithm is pretty straightforward. Then but one thing is that the for loop is maybe unusual, that we actually start from lower to going up. So we actually in the mostly for loop we increase, go upward, but here we are going to down to 1. That means we are taking the floor of array length by 2, okay, starting from here to down, and we are calling heap algorithm with a for this array and with this I, okay. So if you go to the book has this one, okay, we are discussing 6.3 building a heap. So this algorithm, okay, this algorithm we are implementing this algorithm. So the book, it has some intuitive picture, that for instance how do we build a heap, okay. So now let us go to the slide. So here the length, how many elements this array has, 1 2 3 4 5 6 7 8 9 10, right. So then I will be length of a, that means 10 divided by 2, and if we take ceiling or floor over here, then 5 1 0, then floor is 5, right. So then 5, that means we will get this index 5, that we will get 16, right, the 16. So what do we need to do? We want to build a heap. So that what kind of heap? So we know that a heap has a property that all elements, all root elements, okay, are greater or equal to their children elements. So but it does not maintain that property, right. So this part maintains, but this part does not maintain. So what we will do, we got 16, right, index 5, we got 16. Then when we call Heapify algorithm with this a with this array and with index 5, okay, so then what this will be done, this okay, then what we'll do, we again call, so Heapify algorithm will call, we decrease. So you know that Heapify algorithm, it calls itself, right. The Heapify algorithm is a recursive algorithm. So let us go to the Heapify algorithm from our previous slide. So Heapify algorithm, it calls itself, it is a recursive process, right. So at some point it will call itself. So here it will call itself, okay. So with index 4, okay. So then what it will do, so here with index 4, then 4 and 8, this will be to compare, right. And then since that at 4 elements is 2 is less than 14, so these 2 will be swapped, this 2 will be swapped. And after swapping, that the Heapify algorithm will call itself again, since it is a recursive algorithm. So then at this point I will be 3, right. So at I equal to 3, what it will check, so this at I equal to 3 index value is 3, right. So 3, this 3 is less than 10, right. So these 2 will be swapped, these 2 will be swapped. After swapping I will be 2, because it will call itself. Then at this point it will, what it will do, it will go back, and this one will be compared with this 5 fifth index element. So then what it will do, so then this 1 and this 16 will be swapped again. Okay, remember that since the Heapify is a recursive algorithm, so while it came over here, so then it will call itself. So then 5 it will go here, and then it will go here, and at this point it will go here, then it will come, it will check this one. Okay. So after that I will be 1, so then this 1 will be checked with 16, right? This 4 will be checked with 16, then 16 will be then swapped. So then after that, okay, yeah, at this point what we will get this Heapify. Heapify will make a build, you will make a heap, okay, that will maintain our properties, heap properties. All of the elements you see that will maintain heap properties. Okay, so then how many times it is going to be the Heapify is being called? So since it is called, you see that number 1 time, 2 times, 3 times, 4 times. Okay, and starting from 5 times, starting 5, 4, 3, 2 and 1. Okay, so that means the iteration of the loop is starting from n by 2 with floor, and it is going to going down all the way to 1. Okay. So that Heapify time is taking time log n times, and then building her heap is taking maximum n time. Okay, so for building heap, so this is since n element we are making another heap, so that is takes big O of n times, so the total complexity will be n log n. So there is a calculation over here. Okay, how does it takes? The height is LGN, LG is natural log with base 2, and okay, so and we can think that, so this size is n, and that size is this side is log n, and that side is n. So maximum n element, this is a n element. So if we fill out a rectangle, so this will be n log n, total time complexity. Okay, but for the best case it can be big O n. Okay, so now we can jump into the Heapsort algorithm. Okay, so it has the calculation over here. So okay, for the assignment, next assignment I will give you some work exercises from the book exercise. Okay, so now let us come to the Heapsort algorithm. Once we have the Heapify and build heap algorithm, then okay, build max heap algorithm, then Heapsort is easy. Okay, so then there are few steps over here. Okay, so total time will take in log n. Okay, so this part is this is the Heapsort algorithm. But in order to understand Heapsort algorithm, we must first understand the Heapify algorithm that will make a heap that maintains its property. What is the main property of a heap? That all elements, parent element is greater than its children elements. Okay, and then we need to build a max heap. what is called max heap. Max heap, that means the maximum elements stays at the root. Okay, so same algorithm from the book. Here is the Heapsort algorithm. Okay, and this, if you go to these slides, then you will see that some intuitive diagram how the heap sort is going on. So you start from A, B, C, D, E, F, G, A. So there are some good intuitive pictures how the heap sort algorithm is performed and executed internally. And so one thing is that, so that heap sort actually takes total big O n plus n minus 1 big O n log, and this is the length, right? So that actually it takes n log n. So that, as we discussed, as we mentioned at the beginning of our previous lecture, that the heap sort algorithm, it combines the advantages of both insertion sort algorithm and merge sort algorithm. So insert sort algorithm is an in-place algorithm that takes less memory, and heap sort and merge sort algorithm that takes less time complexity, right? What is the less time of complexity of merge sort algorithm was? That was in log n. So insertion heap sort algorithm, it takes in log n and it does in place, because in most of the cases the elements are sort itself in internal places, right? A few places that it is going to be using other places, like whenever we build the heap, then we need memory space. Otherwise we do not need the memory space. Whenever we build the memory space, how much memory we need? Just size log n. Okay, just big O n, that is linear time. Okay, so in our next lecture, actually we discuss the priority keys. So if you understand heap sort, then understanding priorities key is easy, not that much, because in heap sort we develop max heap. Okay, and but we in priority queue we can use that min heap. Okay, so in our next lecture we discuss priority key if it is in the syllabus, in the schedule. Okay, so now let's see, that's it for this week. This is the third week, and okay, okay, so let's see, I have few more minutes. Maybe now what I can do, I can go to a live program. His actually I just so if you go to my Replit account, https://replit.it, at my username Mokhtar MOKTER, then I have programmed a Heapsort algorithm example 1 Java. Okay, example 1 Java. Actually this is the URL. Okay, so if you do a Google search, you will see a lot of examples with Heapsort algorithm, but here is a program. So for instance, the first one is the sort algorithm, and it has Heapify Heapify uh, Heapify algorithm, and you see that actually this sort is the making max heap. You can give another name, okay? So that in our book we have so build max heap. You can rename it build max heap, this one. Okay, so I'll rename that later. Okay, so let us see this. So this is build max heap. So build max heap. Okay, what is called build max heap? The maximum elements stored at the top, right? So then in the main, actually we need to change that one. Okay, so let's see that in the main method. So in the main class I have a print array method. So this is just to print the array elements, and I have any array in the main method, and Heapsort algorithm is whatever I say, obj object, say object, and creating an Heapsort object over here, and okay, I'm calling the build max heap with my array. Okay, so then here it's just printing. So let us run this program and let's see what does it. Okay, so if I am given an array, okay, a list of number in any order, so then after calling the build max heap, so what it will do, it will print, it will display the sorted array in descending order. Okay, so because here we have used okay, so one thing is that this algorithm, so you can practice this one. Okay, so this algorithm, it sorts the array in descending order, right? So then my question will be, how can we display this array in ascending order? Just few changes. Okay, so those are very simple changes. Okay, so I like you to to figure out that. Okay, so spend some time to at this point pause this video for a few minutes, and then think about yourself and how to do that. That means how to sort this array in ascending order. That means the smaller in your part. Okay, it is not a big deal. Okay, so think about yourself for a few minutes, then you see that hopefully this will work. This will work. Hopefully, if I run this, then it will be printed in ascending order. Okay, so but I like you to try to understand what are going inside each of these methods. Okay, so this build max heap is our method. Okay, this is build max heap is taking an array, right? So it is taking an array. So this method is here, and then it is the Heapify algorithm is here. This is Heapify algorithm is here, and then this is just print array is very simple thing, and this is the main method. Okay, so now I like you to compare, to understand this, okay, to analyze this and to convert this program in your favorite programming language, like in C# or C++, whatever language is your favorite language, you can convert it. Okay, so now since I change it, so it should be in descending order. Okay, and that's it for now, and then at the end of this lecture I will give you a quiz. I will make a quiz, and I will give you an assignment. Okay, so that will be due next weekend, by next weekend. Okay, a week from now. Okay, thank you so much. If you have any question, please feel free to reach me during my office hour, or send me an email for an extra one-to-one office hour. Okay, thank you so much, and you have a good weekend.